I am a retired professor. Would like to give a lecture on Introduction to Trigonometry and its applications. This syllabus is 10th standard syllabus. Trigonometry is always refers to a right angle triangle. What is right angle triangle? There are three angles, three sides. If one of the angle is 90 degree, it is called as right angle triangle. The pictorial representation of triangle, right angle triangle is the triangle ABC, three sides, three angles. This angle is called as angle A, this angle is called as angle B, with at this point, this angle is called as angle C. This is 90 degree. Then these two angles are acute angles, less than 90 degree, because the sum must be 180. And the trigonometry is actually give a relationship between the angle and the sides, or this angle and the sides. Trigonometry gives a relationship between angle and the sides, or this angle and the sides, like this. What is the relationship? You can take either this angle or this angle. If you consider angle A, then the sides are specified accordingly. The sides are AB is one side, CA is another side, BC is another side. This side BC, this length BC is called as opposite side, because this side is opposite to the angle A. This angle is under consideration. That's right. The side CA is A. It is called as adjacent side. Adjacent side. Because this side is adjacent to the angle A. The other side, this is one AB, it is known as hypotenuse. There is one more possibility. We can consider this as an angle. If you consider this is also possible. Yeah. If you consider this as an angle, any one of the acute angle, then with respect to angle B, the sides take different specifications. Here, this side becomes adjacent to this angle, this side becomes opposite to this angle. They are interchange. Among these, O becomes A. A becomes O. We have symbolized the sides as opposite side, adjacent side, hypotenuse. Look at the difference. For two different angles, for this angle, BC is O, CA is A, AB is H, is common. Hypotenuse is common in both cases. But only thing, the adjacent and opposite sides are interchanged. With respect to this angle, CA is O, BC is A. This remains same. With respect to this angle, and this angle is related to the sides like this. In this study, we take the ratio of any two sides at a time. Ratio of any, this is a ratio of any two sides. Ratio of any two sides. If we take ratio of any two sides, there are 6 possibilities, because three sides are there. These are the following possibilities. No other possibilities. This ratio O by A, length of opposites, length of adjacent, length by length, units, centimeter or meter, doesn't matter. The ratio is a numerical value. Maybe more than 1 or less than 1. This ratio is called as sine of angle A. It is a trigonometric ratio of angle A. If we take this ratio, it is called as cos of angle A. Here we have trigonometric ratios. 6 possible trigonometric ratios. They are called as trigonometric angles. They are called as ratios, corresponding ratios. This ratio is called as cosecant of A, angle A. I am talking with respect to angle A only. Secant A. This ratio is called as tan A, tangent. This ratio is called as cot A, cotangent. These are called as trigonometric ratios of the angles. 6. If you consider this is the angle, these are the ratios. If you consider other way as possible, this is also possible. If you consider this as angle, with respect to angle B, this becomes O, this becomes A. Definition remains same here, but only opposite sides, adjacent sides are different. The ratio, definitions is same as this, but sides are different. Opposite sides and adjacent sides are interchanged here. The ratio will be different. Here we always call this is trigonometric ratio of the angle B, not angle A. This is trigonometric ratio of angle B. O by H. What is O? CA. What is O? BC. The difference. Okay. But this is possible. Same definitions. And from these definitions, look at this. This is what possible, no? So in this trigonometry, that is, the trigonometry is the one which gives a relationship between the angle and the sides, length of the sides. This is the length of the sides in the ratio. This represents angle between the two sides, or angle between the two sides. 6 possible trigonometric ratios are possible. And from these definitions, these are called definitions of trigonometric ratios of angle. From these definitions, we can able to have these, because look at this right hand side. If we take sine by cos, this divided by this, it becomes this O by A. Therefore, it becomes tan A is equal to sine by cos. This tan A related to sine and cos. This is all. Similarly, if we divide this by this, it becomes A by O. It is as cot A. Or tan A is the reciprocal of cot A. Tan and cot are reciprocal. Change like this. The reciprocal of this is cosecant A. Reciprocal H by O. Therefore, cosecant is equal to 1 by sin A. The reciprocal of this 1 by cos H by A. From these ratios, we can have this. They are interrelated. trigonometric angles are interrelated like this, from these ratios like this. This is how we can, this is how the angle and the sides are interrelated. This is trigonometry, trigonometric ratios of the angles. If you take angle A, what is, if you take angle B, you have this following ratio of the sides. As the following notes can be, we can realize from this introduction to trigonometry. What are those notes? Here, if the angle remains same, the angle between the two lines remains same, the trigonometric ratio, if the angle remains same, even if the side length vary, bigger or smaller, the triangle are bigger or smaller, that is side vary, if the angle remains same, this ratio is fixed, constant. This ratio is constant. This ratio is constant. Trigonometric ratios remains constant. That is one note very important. Because this trigonometric ratio is depending on the angle. If the angle change, the ratio change. If the angle remains same, the ratio remains same. Even if the sides changes. There is a note important. Realize this. And one more equation, very basic equation, it is applied to this triangle is Pythagorean theorem. What is this? X square is equal to a square plus o square. Square of hypotenuse is equal to the sum of the squares of adjacent by opposite, or adjacent and opposite sides. These remaining two sides, Pythagoreans. Equation is useful if you know length of any two sides, the length of the other side can be calculated. There is a significance or importance of Pythagorean. And one more thing, there are 6 trigonometric ratios are there. If we know any one of them, ratio of this or this or this, the other 5 can be calculated. Because this formula is known, from this formula you can calculate the other side. The all other ratios can be calculated. Pass. So with this introduction, let us work out problems on this trigonometry. As I said, if any one of the trigonometric ratio is known, the other 5 can be calculated. Taking a typical example of this, the problem is given tan A is equal to 4 by 3. Find the other trigonometric ratio of the angle A. Put a diagram for this, suitable diagram for this. Right angle triangle, let us call this as angle A. Then see, this side is called as adjacent side, this is called as opposite side, this is called as hypotenuse. Given tan A is equal to 4 by 3, what is this tan A definition? Recall definition of tan A. Opposite by adjacent. It means adjacent side is 4 units. Opposite side is 4 units. Length of this is 4 units. Length of this is 3 units, adjacent side. Units, as you know, length, we can represent now, length, we can measure either in terms of any one of the units, system of units. There are a number of system of units, millimeter, centimeter, meter, kilometer. Length units. Any one can be used. If you use same unit, centimeter only, meter. kilometer, same units. That means length of O is known, length of A is known. 4 units, 10 units. Length of H is not known. Using Pythagoras theorem, it can be evaluated. Look at this evaluation formula. Then put what is this? Simplify. S square is equal to 25, H is equal to root of 25. That is 5. What is that? 5 units. Now we know length of all sides in terms of units, fixed units. You can evaluate the remaining 5 trigonometric ratios. Remaining are sine, cos, cosecant, secant, cot. Write the definitions of sine. Opposite by hypotenuse. Right? What is O? What is H? 5. 4 by 5 is the ratio of sine of A. Similarly, cos is equal to definition A by H. What is A? 3. H is 5. Substitute for the sides, length of the sides. Cos A. The trigonometric ratio of cos A is 3 by 5. Trigonometric ratio of this cos A is 3 by 5. Similarly, trigonometric ratio of cosecant A, definition, was 5 by 4. Trigonometric ratio of cosecant A is 5 by 4. And trigonometric ratio of secant A, H by A, definition, 5 by 3. The trigonometric ratio of secant A is this angle, 5 by 3. Similarly, trigonometric ratio of cot A, definition, 3 by 4. Look at these units. The trigonometric ratio of tan A is 4 by 3 given. The other trigonometric ratios can be evaluated like this. This is how we can solve the problems.